All right, friends, welcome. It is, can you believe it? The last lecture of week 14 of our belt review. So you guys can see the screen, right? With the schedule. Is that
Yeah.
correct? Okay, perfect. Thank you, Graylin.
Yeah.
Cool. So we are in this week 14, we have our belt review. For today's lecture, I have an algorithm. I wanted to stop before that and just make sure, I had said earlier that if there's any questions, I want you guys to be able to send those to me or ask me and we can go over them. If there's anything you're not understanding, I want to make sure that we go over that so you're ready for the belt exam. On Monday, we already went through the entire, what's the word I'm looking for? My grading rubric. So that's there. I told you what to expect. So we kind of hit all of that. I'm happy to tell you anything else you need there, but are there any actual coding questions before we jump into an algorithm? Or things I can make, if you're not understanding login and reg really well, if you're not understanding anything really well, sort of my thought was what we could do is we could do the algorithm and then come back and then maybe do one more. I'm going to spin something up. And when I say, hey, when this gets clicked, what's happening? How are we doing this? So we can get this one-to-many relationship. We can follow kind of visually. We can kind of walk through and see what's going on. That's sort of my idea. If you guys have any other questions, then that can take precedence as well. But how's that sound?
That sounds good.
Cool. Well, there is 5 of us total. So we can either go into breakout room of 2 pairs, or we can just do this together. What would you guys suggest, or what do you think for this
Marvin Gaye.
algorithm? I'm sorry.
Let's stay together.
Cool. Let's stay together. Okay. So it's a little bit of a challenge. We want to reverse a list of numbers in place. So we're going to say write a function that takes in list and reverses the list and reverses the list of numbers in place. What in place means is you can't create a new list. So what you might have thought is we can just create a new list and reverse that and add. In place is a little bit trickier, and it means we can't create a new list. So an example would be is if we take in 1, 2, 3, 4, 5, our output is going to be 5, 4, 3, 2, 1. Okay. Here's some kind of test cases for us. What do we think? Where should we start? Let's say that this was a job, or this is what it was. Where would you start here? Where do you guys think we should start?
Pseudocode.
I'm sorry?
Pseudocode.
Yeah, let's pseudocode it. Absolutely. Cool. So what's the first? Oops. I'm gonna probably take this off. What's the first thing we're gonna do? Let's get very basic here.
Create a function.
Yep. We're gonna create a function that takes in a list. Great. Now, our goal is that, and also when we say takes in, accepts, is given, those are always keywords for saying that your function is going to have a parameter. So that's just always good to know. Okay. So create a function that takes in a list as a parameter. Great. What do you guys think's the next, what's the next step you think we should do? Or maybe we should just name some steps and then we can kind of put it in order as we see fit. What do you think we're gonna have to do?
Loop
Yeah, so we're gonna have a for loop.
or loop.
Yeah,
If condition, maybe.
I'm sorry.
If condition,
Yeah, we're gonna, well, what are we gonna need an if condition for? We just reverse it now.
okay. Variable, maybe.
Yeah, what for? So we're creating a function that takes in a list as a parameter, and our goal is we know that this list is gonna be numbers. And we want to reverse the list of numbers in place. So we know we're going to do a for loop, right? We need to iterate through. Let's break this down. What do we want in this first iteration? What are we going to do? We want to swap these numbers, right?
Switching.
Yeah. So how would we do that?
Is there a command for left or for moving them side by side?
So we're going to do it without built-in functions as well. Yeah, because you could just switch it.
Or we can use temp, like variable temp.
Yeah, Tenzin. Talk more about that. What do you mean by that?
Variable temp, and like we will like put like index 0 and we will change it to like index -1. And we can
Yes.
iterate like till like it came to the middle one.
Yeah. Perfect. And then at the end, we just return our new list. So what Tenzin said is we can create a temporary variable. So anytime you see like in place, you might want to kind of be like, do I need a temporary variable here? Because we aren't able to add like a new, we're not going to like a new list or anything like that. So we want to temporarily keep track of this information. And then after that, we might do something with it. So great job. So if I say def reverse list, and I'm going to say listy. Remember, list is a keyword. So you can't use that. So we've done this. Oh. What we said we're going to do a for loop. Now, Tenzin, you had mentioned we're going to look at the index number of each side, right? We have two types of for loops we can do. Which one of them, and maybe somebody not Tenzin, which one of them uses our index numbers, or which one of them can we use to identify an index number?
Wouldn't that be a for loop?
It is a for loop. We have two types or two ways we can write it. That's exactly right, Liam. It's a for loop. And maybe you guys could just name me the type of, or like tell me how to do the for loops and we can look at it and see which one would be best. How would I write a for loop? Let's just write the first one. Any of them, it doesn't matter.
Let's see, for I in range and then
Yeah.
parentheses parameters.
Exactly. Range is the one that allows us to sort of identify where we're at, right? And where we want to go. So what are my three things I can do? Range takes in
Starting.
3 values. What's the first one?
Starting.
I start. Where do I want to start?
Stop.
Stop. And my step is how many values I want to go to, right? So where do you guys think I want to start?
Would it be len -1, so you start at the end?
We could.
We don't have
We-
to write it.
We don't have to start at the end though, but we could do that. I like where you're thinking that, Liam. That's one way we could do it. We don't have to, but it's one way we could do it. We could start at 0.
Mhm.
Now, what would we want to do? What do we want our stop to be?
In the middle,
Okay, Tenzin, have you done this before?
I've like seen something.
Are you looking at,
I
did you
went to
Google
data
this?
structure, that's why.
Did you Google
No,
this just now? You
no,
liar.
no.
You're- Okay,
I've
why
done
would we,
single.
then why do we want to go to the middle? I thought this was gonna stump you, and then you guys are just crushing it. Why do we want to go to the middle? Anybody?
So that we can change the both sides.
Yeah. So I was gonna let you guys just kind of, we're gonna struggle with it, and it wasn't gonna work, and then we are gonna problem solve, but Tenzin
Sorry
was a
for
big
that.
brain over there and got it all for us.
No.
Let's think about it. If we are swapping these values 1 and 5, and ideally what we're going to then go to is 2, and then we're going to swap with 4 and then 3. If I'm going through my entire length, right? If I'm saying, okay, swap 1 and 5, it does it. Swap 2 and 4, it does it. It swaps, 3, it's not really doing anything. And then I go to the next one. Well, it's going to swap with this one. And so it's going to swap back, right? So it would have been, if the first one we swap 1 and 5, it gets like this, right? 5 and 1. The next one we swap 2 and 4, and it shows up like this: 2, 4, 3. Then if we kept going, we're going to get this 2, and we're going to swap it with this 4. And so then now we're back to 2 and 4. If we go all the way to the end, it's going to swap it back, and it's going to look like this, right? We're going to have flipped it and then flipped it back again. And so that's where we do this half, is we say, hey, we only need to flip these. I only need to go up to half of this, because I know that the back half is already flipped, right? And so that's why we do half of this. We only want to go half of it. Okay.
Real
Yeah.
quick, that being said, if
Mhm.
the list was an even amount of numbers, that wouldn't even matter, right?
We still want to go to half, because either way, even if it was like, 6. What would happen is, let's say we swapped 1 and 6, 2 and 5, 3 and 4, it would look like this. But if we said our for loop continues, let's say we didn't do this, right? We just said, I want to go through the length of the list. It's going to then go to 4 and 3, and it's going to swap those values. It's going to go to 5 and 2. It's going to swap those values again, 6 and 1, and we're going to end up with, again, a swapped value. Or we're going to end up with our original list. So we're saying, hey, 1 and 6, let's swap. 2 and 5, let's swap. 3 and 4, let's swap. Now that we got to the middle, we assume that the right is already swapped. We've already done that. And so then we don't need to keep going. So that's where the over 2 comes from. Does that make sense, Gregory?
Yeah.
Cool. Cool. Okay. Somebody other than Tenzin, because he's taking all the fun out of this. Not really, Tenzin. I'm proud of you for knowing this. Just more so, I thought this was going to take, I thought this was going to be a challenge. And you just hit everything I needed. So now we're iterating through. And what we're wanting to do is we're wanting to go from 1 and 6. We want to switch these, right? How would we start doing that? We said we're going to create a temporary variable for this. But what would we start doing? Or what could we do at the beginning?
I'd probably start by declaring that variable so it can use it. So
Yeah.
temp equals bracket 0 for now until we put stuff in it.
Yeah. Maybe I might even say, because we're keeping, what are we keeping up with here? What's the value, the iterator that we're keeping up with?
Isn't it its index position?
Yeah, it's I, right? Yeah, I is the variable. But yes, you're exactly right. We're keeping up with the index position. The way we're referring to that is via I. So I'm going to say list of I. Cool. Now what I can say is I want to swap these. So now, for right now, let me annotate a little bit. we're gonna have, let's do our good old T bar. We have I at the very beginning. We're starting at 0. Let's pretend that we're doing this top one here, right? So I is going to be equal to what?
0. Well, I guess it would be equal to the value at index of 0, so it'd be 1.
You're right. So you're exactly right. Sorry, I didn't ask that. Great. Yes, you're exactly right. I is equal to 0. Temp,
All right.
you're exactly right. Temp is equal to listy, which is what we're calling this guy, of 0, which is what value, Liam?
1.
Exactly. You're exactly right. Cool. Now, I want to swap my 1 and my 6. So, what can I do here? Any ideas?
Could you possibly set I equal to a different index position and then store it in the temporary variable?
Well, I is
Or-
going to be iterating through, but I
Right.
know that I can use I to access different indexes here. So this first one, we're setting this temporary variable to 1. So I know I'm keeping track of this. Now I want this value to equal 1, right? I want to swap it. I want to say that, hey, this last value equals 1. Or more so, I want to, because I'm keeping track of listy of I, which is 1, let's go ahead and change this. How do I change that? If I wanted to just change this value, what would I do? Let's say I want to change it to unicorn. What would I write?
Wouldn't you just set it equal to unicorn?
I say listy of I is equal to whatever I want it to equal. Now, what do I want it to equal here?
Would that be len of I minus 1?
You're very close. Len of listy minus 1. Now, what len of listy is going to do is it is listy of len of listy minus 1, right? Remember, when we see this len of listy, Python stops and it equates this value to something. So in this case, 1, 2, 3, 4, 5, 6, that is the length of this list. So this is basically saying, hey, listy at index position of 6 minus 1, which is 5. 0, 1, 2, 3, 4, 5, right? So we're saying listy of I, which at this current time is 0. So this one is equal to whatever the value is at listy of 6 minus 1 or 5. So we're basically saying listy of 0 index position is equal to 6. Cool. Now, I know that I can identify 6 or this last value by doing this, right? So what can I do to redefine this last value? What do you guys think? So now this equals 6. So in all intents and purposes, that equals 6 after this line. But I need this to be swapped with what the previous value was, right? So what do you guys think I could do with what we have access to?
Would we potentially be able to make that minus 1 conditional on the value of I so that it iterates through the whole list as we go through?
I love
Basically
it.
subtracting more as I increases.
That's exactly it, Liam. I was gonna let it run and
sorry.
be like, oh, no. Never apologize. That's exactly what I'm wanting. That's exactly what we're gonna do. what Liam was saying is, hey, well, I is going to iterate. And right now it's 0, then it's going to go to 1, then it's going to go to 2, because that's going to be the half of that, right? But if we are just keeping this at -1, it's always just strictly this value. And what Liam rightly pointed out was we're keeping track of I. So what that can do is, I is 0. So let's go back. When I was 0, we're saying, hey, let's target this value. When I becomes 1, it is len of list, which is 6, -1, minus I. When I becomes 1, that's going to be 4, which is now this value. So when we're up on I is 1, which is this index position, it's keeping track here. So it's kind of going back and forth on both sides. That's exactly right. Wow, I thought I was going to stump you guys, and you guys are crushing it. I'm really proud of that. Okay. So this makes sure that we are keeping track with the value on the opposite side of the list. We're keeping track of it as I increases. We're going to that value that we want. Now, the last portion of what I need to do is I need to, again, right here, we've run this for loop. So we've started to iterate through. We're starting at position 0, which technically I don't even have to write a 0. Just wanted to write that for you guys. Remember that 0 is by default. So you can write a 0 or you don't have to. It's already defaulted there. So I is currently 0. We created this new variable that is at listy of I. So in this case, it is 1 is the value. And in this one, we're saying listy of I, which is this index, is equal to 6 minus 1 minus 0. And it's the listy of index position of 6 minus 1 minus 0, which is listy of index position 5, 0, 1, 2, 3, 4, 5. So now our list would look something like this. And so now the last thing I need to do is I need to take this value and I need to replace it with the previous value that was here. Do we have anything in our code right now that was keeping track of that previous value? Maybe something that's a little bit dark because VS Code is saying, hey, you declared something, but haven't used it yet.
I mean, we haven't used that temp variable yet.
Exactly.
But weren't we just gonna push values into it? Or are we just using that as simply as memory?
It's just using it just as a holder because we're doing it in place, meaning that we can't create a new list. We just use this as a temporary variable because if I didn't have this and I said listy of I equals this value, then okay, great. I can swap this to here, but now I've lost track and I can't do a reverse swap, right? I've lost track of that value. So this temporary value allows me to keep track of that 1. So all I have to say is listy of len of listy minus 1 minus I is equal to temp. And so now, because temp is 1, at the beginning, we just set temp. This swaps, and now it's 6 and 6. And then here, we're saying this last 6 is whatever temp's value is, which is currently 1. So we say 1. Then I is no longer 0, but it's 1. Right? So then temp equals listy of position I, which is 1, which is now 2. So temp is now 2. Then we set our listy at position 2, or sorry, position 1. So that's what I is. So this 2 is equal to listy of index position of 6 minus 1 minus 1, because I is now 1, which is listy of position 4, which is right here, right? And so this line now makes this a 5. And then this last line says, okay, this same position, len of listy minus 1 minus I, so a 4 equals temp. Temp was 2, so this goes to 2. Then I becomes 2. Right? Temp equals listy at position index 2, which is 3. 3. Then again, we say listy at position 3 is equal to 6 minus 1 minus 2, which is 3, right? 6 minus 3 basically. So then at listy position 3, which is right here. So now we have this 6544. And the last thing we do is we say listy at len I. So that's that 3, 0, 1, 2, 3 equal to temp. Temp is 3. And we reverse our list. Now, this is why this going to the half is so important, because now we're saying len of listy is 2 over 3. So remember, when we're doing range, it goes all the way up to, but not including, all the way up to, but not including this value, which, can anybody tell me what this equates to? If we're talking about this array right here, or this list?
That would be value 3. So that'd
Yep,
be
it-
the, originally that would be that 4 in the input, but now it would
Yeah.
be at 3.
Yeah, so it's saying once it gets to 3, we're done running this. So now that this is done, right, and we've just done this, I becomes 3. It checks our condition. Now it exits, and we're good to go, right? Here's our new reversed array, or reverse list. Now, had we not, and I just want to point this out, had we not done the 1/2 thing, had we not done this, and we just left it at this, because this is what most students will do, is they'll just say, hey, go through the entire list. At the halfway point, this is what our reversed array would, or reverse list, I don't know why I keep saying array today. I'm not even writing JavaScript for a long time. This is what our, at the halfway point, this is what our reverse list would look like. But what's going to happen if we continued, if we just went through the entire thing? Let's say we did this. What would happen is I is now 3, right? 3 is not 6, so we're good. So we're going to say temporary value equals listy at position 3, which is this value right here, right? And then we're saying, hey, listy of I equals listy of len, so 6 minus 1 minus 3, which is 2. So we're saying this value, or temp, sorry, first off, temp equals listy at position 3, which is, well, in this case, it's still 3. And then we're saying listy of I, so index position 3, is equal to listy at position 2, right? Because 6 minus 1 minus 3. And so it's saying, hey, I, it's now going to be equal to that value. So what it does is we then go and say 4. Right? And then the next line says, okay, index, or the value at index position of 6 minus 1 minus 3, so of 2 equals temp. So we're going to say, and temp is currently 3. So then we say 3. Cool. Then it goes up. I becomes 4. We do the same thing, identifies this value here. It says it is equal to, or we say temp is now 4. Or sorry, 2. Sorry about that. Temp is now 2. They were saying at position 4 is equal to len of 6 minus 1 minus 4. So that's position of 1, which is this guy. So now we're swapping and saying, okay, this is now 5. And then we say that same value is equal to temp. Temp is 2, so this becomes 2. And then lastly, as you can guess, we go up to 5. We go index position of 5, which is this 1. That goes into temp. So now it equals 1. And we change this 6 minus 1 minus 5. So position 0. So this value is equal to position 0. So it goes like that. Position 0 is equal to temp. Temp is 1. Oops. Temp is 1. So this is what happens. So you can see that as we iterate through, we go through the entire list, we reverse it, but if we don't stop halfway, we re-reverse it. So it looks like it didn't work, but it did work. We just sort of reversed it twice. Does that make sense?
Yep.
Cool. Liam and Tenzin, you guys crushed this one. Way to go. So now we just say 2, and then now it's all good to go. Any questions on this? This makes sense.
Could we also have done this a slightly different way? Like, hypothetically, had we done the step thing as like start length -1, stop of 0, and step of -1, couldn't we have just popped them into a variable list and just run through it once?
Sure, we could have, but yes, we could have. But one of the conditions that we had is take in a list of numbers and reverses in place. So in place means you can't create a new list. So if we were able to do that, yeah, if we were able to create a new list, you're exactly right. We could just run through, pop it, boom, we're done. Now, a reason this might take place, like why wouldn't I be able to create a new list, is sometimes when we're doing like embedded technology. You could think of like a, whether it is a smartwatch, something in your car, something physical, like a Alexa, that kind of thing. They have physical memory, and there's only so much allocation. Like web applications and what we're doing, and we use the cloud, in theory, it is unlimited memory, right? Not that we want to pay for all that, but in all actuality, it's sort of unlimited. There's unlimited. It's however many servers and stuff Amazon has, or Azure, whoever you use. But a web application, we care maybe not less, but really it matters when we're dealing with embedded technology, IoTs, which is Internet of Things. Again, that's like your smart bulbs, your smart anything, because that memory is there, and there's only so much of it. You can't scale it up like you can in the cloud. And so something like this, creating it in place, assures that we're not taking up more memory and just adding more, creating new lists or something like that. We're just saying, okay, we want to vary this list, but it's still, at the end of the day, it's still taking up the same amount of memory after this function happens. We're not making a copy, or we're not, using more memory than we need. Does that make sense?
That does, especially when those lists can get up to the thousands or tens of thousands for like users.
Mm-hmm. Exactly. So you might see something, again, it depends on the role that you're doing. Like I said, usually with like web applications, they don't care that much. But with like an embedded technology, again, if that's what you're trying to do, then you want to make sure you're handling memory well. So. And Python inherently, if that's the case, you're probably not going to use a lot of Python, because the way that Python stores data is creates what we call a dynamic array. List and array are the same word, but when we're dealing with data structures, array is going to be the word that you refer to it as. Python calls it a list, but it's still, from a data structure side, this is an array. And so the way that a dynamic, not to get too nerdy, but when we are dealing with dynamic values or dynamic arrays, which is like your JavaScript, your Python, let's pretend that we have memory. I'm going to go very high level here. Let's pretend that, this list takes up 2 of these memory spots because there's 6 values. Well, what a dynamic one will do is it'll buy you a little bit of space. And so though it might take up this much, it might save and reserve this much. So that way when you're adding to it, right? Let's say that this was like 1 through 6. It's going to still take up and it's going to leave you some space. And then if I want to add, let's say I want to add 7, 8, 9, all the way to, 12. I have the room, I have the ability. And if I need to add in 13, it just doubles my space. So even though I just need to add one thing, it's going to dynamically build. It's what we call a dynamic array. And it just allocates a lot of space for me. It could take up a lot of space too. Whereas some other ones, basically you set how big your array is. And then if you want to add, you basically get rid of it. And then you only have the values that you save in memory. So that's what's happening under the hood at a very, very, very high level. It's more complicated than that. But something that we can start talking about, maybe next week we'll do a brief overview, but is something called Big O notation, really called time and space complexity. And really, from a very high level, all time and space complexity is what impact does your function have as n, or whatever your value you're taking in, goes to infinity? Or as n gets bigger, what happens? Right? Let's pretend that we're just iterating through, if right now we have 6 values, right? Let's pretend that we weren't doing this half right here. Let's say we're just iterating through. How many steps does my for loop have to take in order to get through all of my 6 values?
6 steps then, right?
6
Since we
steps,
don't have the
exactly,
half.
right? Exactly. If my list had 1,000, how many steps would I have to take in order to get through this entire list?
Well, that'd be 1,000 then, since we're only
Exactly.
evaluating one at a time.
Yeah. So it is a linear, what we call a linear relationship. As n increases, so does my time. So the more values I have, the longer it's going to take. This is what we would call O of n. Time and space complexity, or linear space complexity. What is O of n? We can get into that, and I'll kind of give you that. But just kind of thinking at a high level, what impact does n, or we always say n to represent like a parameter. As that gets bigger, do I have more steps or do I have less steps? Now I'd be curious, I'm not quite sure, I haven't done the math, but of this O of 2, here we have 3, and then here we've got 500. So it's still growing. So I think it'd still be O of n. But let's say that all our function did. I'm just going to do this. All our function did, let's say it took in a list. I knew that that was going to be that. And then all I did was print the first value. This is all my function did. If I've got 6 values I pass in, how many steps does it take to run this function?
Well, just one, right? Because it's only
Just
printing
one.
the first value.
Yep. If I've got 1,000 values here, how many steps does this take?
Still one.
Still one. That's exactly right. So that's what we call constant time, or O of 1. This is the most optimal, saying it does not matter how big n is. N could be 5 trillion. Doesn't matter. There's no effect on how much time it's going to take me to run this function. So that's what we call O of n, O of 1, which is constant time. And I will probably just do a pretty good breakdown next week of O of n And because this is what we call linear. When you do an algorithm, and you're going to learn about this in projects and algorithms, so this is not like the only place that I'm kicking you out and like, good luck. But when you do an algorithm for a job, so when you go and apply for a job and you do a technical interview, if you have to, they're going to ask you a question. Now, it's going to likely be harder than this, but it's going to be some sort of question. It's going to be some sort of algorithm. And at the end, they're going to ask you, what is the time and space complexity of that algorithm? Time being how long did it take for your algorithm to run in respect to n, or whatever values, how many values you took in, and then how much space did it take? Here, we're not adding or taking up any space, right? So our space complexity would also be O of 1. We're not taking up more space or anything like that. And even here, really all we're doing is creating a temporary variable. But I think you could say that that's also O of 1, right? If I was creating a new list or I was iterating through and creating a whole bunch of stuff, that's when we get into some issues and some space issues. But what they're going to ask you at the end of the algorithm, once you solve it, so it's not enough just to be able to solve it, you have to know the time and space complexity of that. And we can talk more about that. But from a very, like, just these are only two, there's a whole bunch of time and space complexity things, but do these make sense? As n increases, the time, for iterating through and just printing every value.
Yeah, I'd say it makes
Yeah.
pretty good sense, and I would definitely be interested in getting more in depth on that, as that's probably pretty important when scaling up applications. I bet
This will
everyone's
be-
looking for it.
This will be very, very, very important. Like, I would go so far to say that if you don't know time and space complexity and you get a technical interview, you probably won't get a job. Like, it is that important. And that is something that's what the entire next course is about, is algorithms and time and space complexity. And so what should be happening is anytime you do an algorithm, this is my biggest, like, I'm imploring you to do this. Anytime you do an algorithm, after we go through big O notation and what that means, right? You have to have that understanding, or else, that doesn't make sense. After we go through that next week, anytime you're doing an algorithm or problem that you're practicing, you need to practice the time and space complexity. So a great way to do that is to, here's my biggest, like, life hack, if you will, is go to ChatGPT or Grok or Claude or Gemini, whatever you decide. I like Chat. I'm already in too far. And you can say, what is the time and space complexity of this algorithm? Now, whoops. Now, what I would say is, don't just immediately go to it. Try to figure it out yourself. I said that I'm curious if it's O of n. I still think it's O of n, because as O increases, even though we're only going through a half, it still is bigger. But that's kind of what, just from the top of my head, that's what I'm thinking. But do this and then say, okay, I've got what I think my time and space complexity is. Now, what is it? So time complexity, the loop iterates over half the length of the list, which is denoted in over 2 times, equals O of n, which is exactly like what I was saying. And the space variable O of 1. Yeah. So great. That's exactly what I thought it was, right? And we can get into, what does all this mean? The second thing you can do is, and this is like the biggest thing you can do for your job. So like, please, 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 please hear this, is then say, okay, is there, so after you write it, make sure it's working. You say, is there a more efficient way to write this algorithm? If so, please document and explain all of the changes and why it is more efficient. So then what it will do is if you, let's say you write a really bad algorithm, but it works. What this can do is, like, this is another way to write it. It's, to me, that's very confusing. I don't really love that. But this is another way to write everything we did. That's exactly what we could have done instead, and that would have been the same thing. But what this will do is this will get you to start thinking about, here's other ways I could have written this code. And if it's documenting, okay, this is more efficient. You know, if it's a really bad, we do a really bad job and like, oh, I could have used this tool that makes it more efficient. It's just a way that we can practice that. But you have to first try to get it to work, right? Or get it to work. Then you have to predict your own time and space complexity. And then that's when you say, okay, check it. Okay, this is what I think it is. Tell me what it is and why. Okay, I was wrong. Okay, but now I know, right? It is this because of this. I didn't think about that. And the second thing is, you know, how do I write it better? And that way you can practice and learn. You guys should be doing this once you get into projects and algorithms. Makes sense?
It
I don't mean to
does.
I don't mean to stress you out,
Yes,
but it's just a
yes.
tool I wish I would have had.
Mhm.
Because transparently, I did the full-time program. And we did algorithms in the morning. I didn't take them very serious because like this, I don't care. And also more so, I didn't really like doing them. And I had job. I was able to get interviews at really big companies that would have like changed my life. And had I taken this more seriously, I could have worked there, if that makes sense. Right? Like if that was the thing that was preventing me from getting that job, is I couldn't pass the technical interview. And so then I had to go back and learn it, and then I was able to get a job through that. But this is something that if I'm telling you, they can take, if you know CRUD and you know Python, that's great. You can learn more on the job. This is going to be a stopgap. If you don't know how to do this, you will not be able to get a job 90% of the time. There are some other companies though, like what are some companies that do not whiteboard for STB sessions? So here's a great thing called hiring without whiteboards. So here is like here's all the companies that don't use whiteboards. So if you're like, I don't want to do technical interviews, here's a lot of the companies that maybe won't offer you or won't make you do that. So this is a great place to start. I don't know any of these, but if you don't want to do that, this is another way to not stress you out.
Good to know. A quick
Yeah.
question about the revised algo, though. As far as
Mhm.
slicing is concerned, is that considered a built-in function or just more of a core code function?
It would be built in, and I'm actually curious because from my understanding, a slice. I have to see what exactly we're doing. Reverse using slicing, because what I was under the interpretation is that slicing under the hood actually makes a copy of your list. So I would have actually thought it'd been worse for space complexity because we're making copies. So I'll have to look into why it says that this is better.
looking at the description, it says it reverses it and then assigns the list back to itself. Maybe it's because it only temporarily uses that extra space. It might be interpreting
Maybe.
it as O of 1. Because
Yeah,
at the
maybe.
end is the same as the start. It's the process that creates more temporarily, it looks like.
Yeah, so then maybe, here we go, yeah. Well, slicing method is more succinct and Pythonic from algorithm. Have a simplicity of this.
Okay, it looks like it goes into
Slight
that.
overhead due to
Yeah.
the creation of a reversed copy before the assignment. Generally negligible for most practical. Yeah, that makes sense. Yeah,
Well, that's definitely good to know. I'll be using that tool, in the future for above the board concepts and stuff. I think this is going
yeah.
to be very handy.
Yeah, absolutely. And so what we'll do next week is I'm not going to talk as much about like circular imports and relationships advanced, just because I believe there's stuff on the platform that does that. What I'm going to do is next week we're going to talk about APIs. The reason that is said is or the reason I'm doing that is because APIs is something you will need to understand how to use. Like I'm just talking very real world perspective. I always am tasked or I'm often using APIs to query data, to do certain things. We need to have practice at retrieving data from an API. How does that work? What is JSON? How do we take in JSON? How do we read that? So using fetching data, grabbing data, that is going to be something that you might even have your own company's API, right? Your company might have its own API that we're querying and grabbing. That is going to be something that's going to help you a millionfold comparative to like a circular import. What a circular import is like if I'm saying here, let's say that I required, let's say that, for example, a circular import would be this. Like if I said from belt exam dot controllers dot users import users or import let's see index, we'll just say import index. Well, I'm saying that in order for this file to run, I need to go to controllers and I need to bring in the index. I need to go to my users and bring in index. But what this is saying is that in order for this file to run, I need to go into my models and import my user. If I go here, I'm saying in order for this to run, I need to import my controllers. And so that's what we call a circular import. Each file is dependent on one another. Therefore, they can't work without one another. And that just creates a circular import that doesn't work, right? Because this requires this, but this can't exist without that other, but the other can't exist without that file, right? And so it's just this inevitable cycle. So that's all a circular import is. So if it says like circular import, and that no just at one of your from, kind of tops, there's an issue there. That's it. But that's what we'll do is we'll talk about APIs. And then what I'll likely do is I do a lesson. Maybe we'll introduce APIs here. Well, let me ask you guys. Every major stack, especially the ones that are going straight to projects and algorithms, so that's you guys. I always offer to do a lecture on things I wish I would have known leaving a boot camp. This is a lecture that I talk about salary negotiations. I talk about, and I'm super transparent with like salaries. I talk about like what is equity versus like options versus stocks. Like if you go work at a big company, then you can get stock or equity or options. And what that kind of equates to, because that's stuff I didn't know when I first got hired at a big company that offered equity and stuff. I was like, I don't even know what that means. So I talk about that. I talk about like ways to negotiate your salary, kind of keywords to say. tools to use on the internet to like apply to jobs, to compare your salaries, and just give you my insight. That is something that I'm happy to do. If you guys are like, I'd rather learn about APIs or I'd rather like learn more about Python, I'm happy to do that as well. Totally up to you guys on whatever you would like to do.
Well,
Would
that
that be
all sounds
something-
like
Both of
very
you.
valuable information on
yeah.
both sides.
I'd like to hear about the
Yeah.
APIs and that.
Okay.
Yeah, that.
Yeah.
Okay, cool. So why don't we do this? We'll do next week on Monday. We'll do so that way we're like continuing the conversation of APIs. Next week on Monday, I'll do the here's what I wish I would have known. And then that way it's not like the last week. And if you guys are like, oh, I gotta get my exam, but I want to go to this, I'm stressed. You know, you still have plenty of time. Here's what I wish I would have known. I'll go through my offer at Twilio, like salary wise, equity wise, benefits they gave, what I could have negotiated, what I wish I would have negotiated, tools that you can use to negotiate, platforms to go find jobs, because there's lots of good ones out there that are kind of hidden and secret. Different tools like that. So I'll do that Monday. And then that'll take up the whole class. And then we'll start APIs here. And then in one of the maybe this office hour, I'll do like a big O notation walkthrough. I'll do that. Yeah. I don't even know what this is. Kill me. So I'll do office hour. And this will be recorded too. Now, you're going to learn about this in the next one, but I would say having double knowledge of big O notation is going to help you a lot. And then this will be, let's call this. Call this lecture APIs. Cool. We'll do that. And then we'll just build in, maybe integrate. I'll just whip something up and we'll build in and integrate like a Google Maps or some sort of API, because APIs are also for your personal projects. That's going to really set it apart. If you can use the Spotify API and you have music playing, or, you know, you have some sort of map, or, and just to show if somebody's looking at your portfolio, like, hey, it's not like just this CRUD functionality I built, but I can actually take in data from another source and I can do a bunch of things with it. So we'll start that and then finish that up this week as well. Kind of make it as big as we want. So cool. Again, what to expect for Friday is I will check, make sure that you have all but one is 90% of your core assignment. So everything but recipes, though I would suggest for you to do recipes before you try the exam. Friday, I'll send out a code, send out an email with all the information. I'll send out a code for you. And then that'll be in the morning. That code will be good up until midnight on the 26th. So no pressure. But it is good just for that one, but up until the 26th. But if you take it early and you want to get as many, remember you get up to 3 retries, then you need to probably start the first one. Depends on however long. It just, you have up to 3, but the last one to start, last day to start an exam is Tuesday. So work it on the weekend. Just as a reminder though, when an exam is opened, you cannot ask a question in Discord about it. You cannot ask a TA questions, and don't ask like general questions, like, oh, how would I add this? Because TAs are gonna, what they're gonna do, they know that it's exam week. TAs are gonna go in and we have a little tool that we can log into, and we can see that you have an open exam. And so they might tell you, hey, sorry, you have an open exam. This one asks that. Or if you go to Dojo Hall, we can see that you have an open exam, and they won't help you with anything. Even if you're like trying to be sly and like, oh, this one assignment, this one thing, they can be like, sorry, you have an open exam. I can't help you. So, and those exams last for 24 hours once you open it. Again, the code's good until the 26th. Once you go to your login, and then you go, let me go to the actual class. Once you go to take exams and you put in that exam code, once you click unlock, your 24-hour countdown starts. So, yeah. And then I should have them all hopefully graded by like Tuesday. And then if you need to retake, you can. But if not, that code's still good. And we'll have next week. And then can you guys believe that you are a week and a half away of finishing Python? Is that insane or what?
It's
Crazy. You did it.
Definitely feels like I've been here a while.
Yeah.
That's crazy.
Yeah, y'all have. The thing I would say, not to get too emotional, I know it's 6 o'clock too. Going up to exam can feel very stressful. I've been there. I know that test anxiety is a very real thing. Something I always like to remind students, especially before starting an exam, as a little ego boost, is think about where you were at day one and how impressed with your day one or how impressed your day one self would be with your current self and the knowledge that you have. Inherently, you have more knowledge about Python than you did 16 weeks ago. You should be very proud of how much you've learned in 16 weeks. And it should give you a confidence boost of like, no, I can do this, right? Because if you were to try to tell your day one self of Python, hey, go modularize a Flask application, set up a MySQL like a MySQL database, and just even be able to create a user with a login and reg with a hashed password, you'd probably be like, whoa, I'm gonna have a breakdown, right? You guys can all do that. You guys know how to do that. So just be very proud and kind of have some confidence there. So. Okay, any questions? We're 2 minutes over. Any questions at all?
None here.
Perfect. Great job today on the algorithm. You guys crushed it. You guys, I really thought I was going to stump you and you guys dominated it. So way to go. I'll stop the recording here.